Okay, so unfortunately, Dot's already given the highlights of my talk, but you'll have to sit through it again anyway. Um, the main thing we're focused on at the moment is upgrading our ground gravity coverage so that the whole of the NT is covered with modern data at 4 kilometre spacing or better. So the Pine Creek survey, which is outlined in pink here, it was covers an area of about 40,000 square kilometres, primarily at 2 kilometre spacing. Over 12,000 stations are planned, and about 4,000 of these stations have been funded through collaboration with industry. At the time of this talk, the survey is about 80% complete before they had to demobilise for the wet, and hopefully they'll start up soonish in May or June, depending on access, and we'll finish off that survey. So shown on the left here is the pre-existing gravity, with the station locations shown in black. So you have old 11 kilometre space data, which is probably barometric level, so not very good quality, along with a few profiles and a 4K survey down here. This is the planned new stations, infilling the existing 4K to 2K, the rest at 2K except for national parks and a number of industry infill. On the left here is the pre-existing gravity, and the right figure shows the new gravity. It's also been updated on the gravity map at the back if you want to have a better look at it. And that's the first vertical derivative of the gravity pre-existing on the left and the new data on the right. Moving forwards, we've got 2 more surveys to complete. So the West Arnhem survey, outlined here in purple, that'll be all acquired at 4 kilometre spacing and should hopefully kick off as soon as the Pine Creek is finished and be completed this calendar year. Currently planned around just under 4,000 stations will be acquired, and we're just reaching out to industry now if anyone is interested in participating at that survey to acquire data at 2 kilometre, 1 kilometre or 500 metre spacing. Following that, in the next calendar year, we're going to do the South Georgina Basin Gravity Survey. Oops, I lost my arrow, shown here in green. Okay, that's again going to be a 4 kilometre space survey over around 58,500 square kilometres. So just over 3,500 readings will be taken, and again, industry will be approached and given the opportunity to participate as we get closer to that survey. Okay, next I'll run through the 11 projects that were completed under round 16 of the Geophysics and Drilling Collaborations project. So all of these projects and data sets are now open file. The projects covered active and passive seismic, airborne EM, airborne gravity gradiometry, ground gravity, and some seismic reprocessing. So 2 surveys were completed within the Pine Creek origin. Mangusta Minerals acquired an AEM survey shown here in green, and PNX Metals acquired ground gravity shown in blue. So the Mangusta Minerals are, each of these slides will have the CR number at the top. That's how you can access the data and report for these projects. The Mangusta Minerals AEM survey was flown over the Fenton Shear Zone around 100 kilometres northeast of Katherine. The survey was acquired using the sorry, my screen just changed. Using the SkyTem system, flown at about 200 metre line spacing over an area of 150 square kilometres. So the project's exploring for shear zone hosted orogenic gold. What I've shown here on the left is a depth of cover map, or a depth to basement map that was created from the data. So that extends from about 500 metres depth in the southwest to 50 metres depth in the northeast. They're also using the data to look for basement conductors. The middle image shows a mid-time conductivity, and the right image shows a late-time conductivity. And in that late-time conductivity, they've identified some conductors, including Fenton North and Fenton South, for further follow-up. PNX Metals acquired ground gravity data over the Moline project, approximately 80 kilometres north of Katherine. The pre-existing data there is that old 11K data, so the black stations are shown on the left on the pre-existing gravity. The new stations are shown on the right, acquired at 500 metre spacing over the entire area. The project's exploring for base metal mineralisation, and the survey was designed to identify intrusions at depth. Again, on the left is showing the pre-existing gravity, and on the right is the gravity from the new survey. You'll all be happy that I don't interpret any of the data myself, and unfortunately at the time of reporting, the processing interpretation of this data was still underway, so I can't tell you what they found. But the survey did sit within the Pine Creek Gravity Survey. So what I've shown on the left here is in pink are the planned stations for the survey that we're currently acquiring, or actually they're the acquired stations. And the white stations were the stations as part of this survey. This is the survey gravity overlain on the Pine Creek gravity, and you can see these ridges starting to run through the two data sets, and that was what was visible before the two surveys were completed. In the MacArthur Basin, there was one airborne gravity gradiometry survey acquired by TBG Resources, and Theo's here if you've got any detailed questions on that survey. The survey was flown over the Walker Fault Zone in East Arnhem Land. It used the Falcon system, flying at a line spacing of 250 metres. On the left is a pre-existing gravity, which is primarily 4K based. And on the right is a conform to ground gravity from the new data. This slide here shows the first vertical derivative, so the actual airborne gravity gradiometry on the right image. The survey was designed to identify gravity responses associated with sediment-hosted zinc-lead silver deposits. Some zones of high density, apparently controlled by north-northeast trending faults, have been identified in this new data set. In the Tanami, 2 surveys were completed, one ground gravity survey by Prodigy Gold and reprocessing of seismic data, of existing seismic data by Newmont Exploration. So the Prodigy Gold ground gravity survey was acquired over the Tanami North project within the Superjack shear zone. The pre-existing data in the area was 4 kilometre spacing with one area of high resolution within the survey area. And here are the new station locations at 400 and 800 metre spacings. The project is targeting gold, with the survey designed to help understand the lithology and the structural architecture undercover. Again, at the time of reporting, the modelling interpretation of this data was still underway. However, the image on the right there shows the gravity from the new survey. I think Gary's around too if you want to talk more about that one. Newmont Exploration reprocessed some existing seismic located near the Oberon and Kelly deposits. That's Oberon and Kelly. This is the pre-existing seismic, which was acquired by GA in collaboration with NTGS, GSWA, Newmont Exploration, and Tanami Gold back in 2005. Okay, so the aim was to identify broad-scale architecture, geometry of deep-seated structure, and potential fluid pathways by reprocessing the seismic data. On the bottom there, I've shown an interpretation of the seismic that was supplied. We've identified some large-scale thrust. Oh, sorry, I should say that there is north to south of, I can't quite see this, but this western line. So they've identified a number of large-scale thrust faults, shown here in red, on both of the seismic lines, and also areas of washed-out seismic response, which is shown here in yellow. Some of these align with known granites, but some of them don't, which also suggests that there may be some unresolved granites in the area. Within the Aileron province and Iridina province, 3 surveys were completed. So IGO completed 2 AEM surveys, one shown here in the lilac, down here, and this big one here in green. And Investigative Resources acquired ground gravity just in here in the light blue. So the first of IGO's AEM surveys was flown over the boundary between the Aileron and Iridina provinces. I'm just zooming into this area here. The pre-existing data, TMI data is shown here at line spacing of 500 metres, and the new survey was flown at 300 metre line spacing using a helitem system. The project is exploring for magmatic nickel sulfide mineralisation, and the survey was designed to directly detect conductors that might be associated with mineralisation. Shown here are 3 different conductivity depth slices from the data. So on the left, you have the 100 metre depth slice, in the middle at a depth of 200 metres, and on the right a depth of 400 metres. 2 anomalies have been identified for further follow-up within the data, and data from the survey at the time of reporting was also being used to generate a detailed conductive cover regolith map. Investigator Resources acquired ground gravity data over the Molly Hill area, located about 330 kilometres northeast of Alice Springs in the Aileron province. They acquired at a range of spacings in an area that was primarily already 2 kilometre space data. They acquired at 20 by 40 metres, 60 by 120 metres, and 100 by 200 metre spacings. The project's exploring for skarn mineralisation that's associated with large granitic intrusions. Several gravity anomalies have been identified in the new data, which is shown there on the right. I think you've got Molly Hill and Pinnacle Hill marked here as well. One of those gravity anomalies to the east of Molly Hill is being interpreted as a possible offset of the Molly Hill deposit as well. The second IGO AEM survey was very much a regional data set acquired over the eastern portion of the Willara gravity ridge in the Aileron province. Shown on the right here is the NT-wide ground gravity with that Willara gravity ridge, and that's the existing magnetics in the area. Oops. Well, they used the Tempest system. They flew at 2 kilometre line spacing to cover such a large area. Projects exploring for magmatic nickel copper cobalt mineralization hosted within mafic intrusions and also pegmatite hosted lithium mineralization. So the AEM was flown to map areas with shallow and moderate cover so it can help inform further exploration techniques. And it's also going to be used to generate a conductive cover map as well as identify discrete conductors. Shown on the left here is again an early conductivity, 20 to 30 metres, 60 to 100 metre conductivity, and oh, that label's wrong. Sorry, I think that's going to be 40 to 60, and that'll be 60 to 100. You can see, even though it's 2 kilometre space data, that it does actually grid up quite well and show some continuity of the structures. In the Warramunga province and East Tennant area, 2 surveys were acquired during the round 16. Both of these were passive seismic surveys, but using different techniques. So Knox Resources acquired an ambient noise tomography survey, which is shown here in the blue over here. And then this here was Castile Resources passive seismic survey, shown here in the red. So the Knox Resources ANT survey was designed to explore undercover in the eastern Tennant area, about 170 kilometres east of Tennant Creek. There were 3 deployments of 64 stations each. They're shown with the white dots on the right image at a station spacing of 600 by 600 metres. The velocity variations in the new data have been used to interpret boundaries between the Georgina Basin, the Elroy Formation, and the basement in the area. So that left-hand image shows the base Georgina Basin, which is interpreted at 2,500 metres per second. The middle image shows the base Elroy Formation, and the right-hand image shows the top Proterozoic basement. This line here is approximately where this section is from, so they've also identified possible South Nicholson sediments in the northeast of the survey area. Unfortunately, Castile's Resources passive seismic survey was only partially completed over the Rover 1 IOCG deposit, approximately 100 kilometres west-southwest of Tennant Creek. Because shown there in the black sites was the original planned stations, but they were only able to acquire those 3 shown in the white dots. So they're only able to do some horizontal to vertical spectral ratio of those individual sites. They still did find from those results that one of those stations shows the basement paleo surface. Subsequent to the GDC project, they have completed a proof of concept ANT survey. Unfortunately, I can't show you those results, but it's successfully imaged to a depth of 600 metres and identified the ore body at 280 metres depth. One survey was acquired in the Amadeus Basin, shown here in pink, using active seismic by Central Petroleum. So the survey acquired 20 kilometres of seismic in the west of the Amadeus Basin. The project's targeting the Zevon lead, which is a large subsalt structure with potential for hosting hydrocarbons, helium and hydrogen. So that's the survey line there. The survey was designed to test a few things. One is, what were the optimum acquisition parameters, whether you could successfully use a weight drop source to return acceptable data in the area, and whether you could image the hereditary formation, which is the reservoir target. So shown on the right there is the interpreted seismic, showing the heavy tree formation interpreted in blue. So the survey did conclude that the target formation can be imaged and that the weight drop method is suitable for acquisition of seismic data at this project. Um, that's all I've got on the different surveys, and the reason I sort of put them out there is you can see what techniques are being co-funded through the GDC and hopefully successfully apply some of them to your own surveys. All of those data and reports are downloadable through GEMIS. The NTGS Pine Creek Ground Gravity Survey we're releasing preliminary data through the Resourcing the Territory website, and we'll continue to release updates to that once the survey gets going again. And yeah, that's everything. Thanks.